to set that there. All right. Good afternoon. Let me get the clicker here. So, first of all, do we have anybody here that's not in the honors class that's joining us for the AEC experience? Nope. All right. So we do have about 7 people online. So that's great. We appreciate that. There is one presentation that has a poll in it. Unfortunately, it looks like they've taken the poll opportunities out of Teams, so I didn't know how to do it, so we'll just do that in the class here. Sorry about those people online. So this is, yes, ma'am. It is not working? Okay. Yeah, I don't know why that wouldn't be working. Bear with me just a second. Yeah, I don't know why the Teams chat is not working. So I apologize. We may just have to have you raise your hand or something like that and figure out how to engage you later on. Anyway, so this is the first session of the second semester. So it's session number 5 of our AEC experience. So we're capitalizing on a unique opportunity where we've got 3 major projects coming out of the ground, all within a very close proximity to each other on the USF campus. So we're actually talking about different aspects of those projects. And while we're doing it, we're taking an opportunity also to teach you a little bit about design, construction, and what it takes to build buildings like this. So let's see if, yep, all right. So we are, as I said, in the second semester. This AEC experience encompasses in-person tours. You'll get to tour the job sites twice a semester. So we also have a tool that you can tour virtually. You'll learn about that today, that you can walk around the job sites virtually, which is pretty cool. There's also webcams. So all of that, if you just Google USF AEC experience, you'll be taken to the facilities management webpage that outlines all the opportunities there. Right there in the bottom right-hand corner. Also, if you want to, you can join us on the Bulls Connect and connect with us. So this is a fairly recent photo taken. You can see the Honors College on the left of the screen, the Wellness Center in the right-hand side of the screen, and all the way at the top right, you'll see an area of sand. That's our sandbox that is now the indoor practice facility. They're building the foundations for that, and probably in about 2 weeks, you'll start to see some big steel going up over there. Today, what we're going to be talking about is how other technologies are used to support the design and construction process. You may think, well, I'm in computer science, information technology. This really doesn't apply to me. Well, you'll see how a bunch of, and I use this term affectionately, a bunch of geeks from, I think it was MIT, got together and started a company called OpenSpace that is transforming the way we document construction projects these days, incorporating artificial technology. Francis will talk about that. Talk about how we do research about the existing sites that we weren't able to do a few years ago. So today we have Daniel Gessman, and I'm just going to refer to these guys. So if I rode over in an SUV from our office today, it's like driving with the Three Stooges. So Daniel Gessman is our GIS analyst. He'll tell you about what GIS is. Richard Piccinini is our university civil engineer. And Francis Dugan, who is going to join us online, and we'll figure out how to pipe him into the speakers. He's going to give us a demonstration of OpenSpace and what that is and what that software tool does. And then Rob Baynard is our quality management coordinator. He's going to talk about some of the technologies we use to actually figure out where our buildings are leaking, how we maintain our roofs, how we look for that kind of stuff. You may think from a science standpoint, this is really cool to actually use some of this technology in actual application, how it's actually employed. So I'm going to turn this over to Daniel Gessman, and he's got it here for you for a few more minutes.
For a few more minutes, Okay, so I will start over here. So I'm Daniel Gessman. I'm the GIS analyst within the Department of Emergency Management here at USF. We are also within facilities management. We are pretty much mapping everything throughout the university above the ground and below it. So in my presentation, I'll talk a little bit about kind of what GIS is and talk about some of the projects that we've done at USF and the enterprise GIS that we've built. And then kind of once we take all that data, what do we do with it? And then that not only relates to my presentation, but then relates over into Rich's as well. So I will start. Let's see. Does anybody know what GIS stands for? Now, I know you know how to spell it now, but does anybody know what it stands for? We got, what number is it? What number, you guys got 3? Yep. Yes, so it is Geographic Information Systems. And there's the long definition on here, or at least computer systems capable of assembling, storing, manipulating, and displaying geographically referenced information. So it's a way of taking points, lines, and polygons and attaching a X and Y coordinate to it and putting it somewhere on the map. The easiest way to describe it is taking the real world and breaking it down into individual layers. So that would be starting all the way at the bottom and working at who owns that land. You have parcels, you have boundaries, you have easements, and then kind of working your way up on that. So you have green spaces, you have ponds, lakes, then you'll have sidewalks, parking lots, buildings, trees, and just going from there. And then for how it's kind of used today, kind of would relate to kind of many of the majors that are in here. So it kind of is used in multiple different aspects. With business and marketing, it's used with data analytics. With environmental, it's looking at tracking environmental impacts, animal migrations. With health, COVID-19 has been an absolute huge one as of late because they've been tracking the numbers all throughout the United States and all throughout the world. And then also just planning, engineering, and utilities as well. So knowing what's under the ground and then knowing, hey, we want to put a new building in the ground. We want to put honors. We want to put wellness. We want to put a practice facility. Hey, maybe we want to put a football stadium. No? Okay, nothing out of that one. Maybe. But we need to know not only like what's under the ground, but then what is the impact of putting that structure on the ground as well. Maybe. Oh. No? Okay. One more. Okay, perfect. So again, some of the ways that GIS is used is a big one is in decision making. Is obviously influencing policies, is determining what is the scale of said issues that are on the ground. Asset management, what do you have? Where is it? What's the information that you need behind it? And then taking that information and also modeling it. So being able to create a system where you have points representing valves for a water line, and you have a water line connecting all the way down further down the street. If I turn this valve off, what's the impact down the line? So we can actually model systems like that, especially in Rich's presentation. He's going to talk about a little bit about stormwater and how when it rains, what is the impact? Will our system be able to handle that 100-year flood? Maps and presentations, so visualizing data. It's really a much better way to view things. I mean, I can imagine you guys looking at an Excel spreadsheet every day would kind of get really boring. So in this sense, is taking it and putting that information into a geographic reference and being able to see some of the information. And then determining change over time, like looking at condition assessments, looking at what are the conditions of our utilities in the ground? Like what over time do we need to replace those? And again, rounding it all the way back to decision making. So as you can see, some of the images we have is one of the 3D models that we've built with using BIM. And this was actually taken with imagery. And then some of our utility networks throughout. It looks like a mess, but we somehow know what we're talking about. Next slide, please. For some reason, the clicker doesn't want to work today. Oop. So here we are. So in relating to what you guys have been listening to lately, we've built a GIS system here at USF. And where we really started was with AutoCAD drawings was all we had. So all we had was points, lines, polygons in a CAD drawing or in a PDF, and you really didn't know what you were looking at. You couldn't click on a manhole and have it telling you all the elevations associated with it. You couldn't click on a building and have all the building information associated with it. When was that building constructed? Who owns that building? Is it leased? Is it owned by the state? Versus, et cetera. So really, we didn't have any of that. And then we converted all of our CAD drawings into, or at least all of our CAD drawings into our base maps into GIS. And then kind of where we are today, we've worked with the library to build a facilities enterprise GIS, which I'll talk more on the next slide. And then we've also have BIM, CAD, and FAMOUS, which is our asset management system. And really, that's how the drawings come in after a building is complete. We receive those drawings in, or we receive those list of assets associated, and we tie those into either our asset management system, or we relate all those utility drawings and civil drawings into our GIS system. There we go. So for the computer science folks in here, built an enterprise GIS system working with a company called Esri. They are essentially the sole source for all of GIS, or at least the majority of it all. So we did a enterprise build out where we actually build it all throughout facilities. So we built it throughout our organization. It allows people to manage, share data, visualize data, all in the palm of their hand. So really it's all in a tablet on your phone, and it's everything from our marketing team going out and mapping what are all the wayfinding signs on campus that you guys see along the roadways. It's our utilities guys knowing where the utilities are throughout campus, and really then allows us to build custom mapping applications to manage that data even better, to allow people in the field to relate information back to us. So some of the big projects we've been working on are the one we're looking to roll out in the next few months here is our interactive campus map. It really is I have one more slide about it next, but it really allows students, visitors, faculty, staff to really get a full view of the USF campus all on a computer screen. We did a 3D campus model of Tampa. We've done some story maps for the Institute of Research and Art. We handle all the annual publications that go out through Parking and Transportation. And then for emergency management, we've actually developed some internal applications that allow us to track storms throughout the season with data that's coming in on I think a 3-minute interval from the National Weather Service. I'll give, there's, yeah. Oh, Steve, please. So a little bit more about our interactive map that we're developing. Like I said, it's a one-stop shop for USF information, for public information. Everything from buildings, services such as where is your dining, where are the Federal Credit Union spots, where are all the departments within those buildings, where are your gender-neutral restrooms, where are your blue light phones, etc. The list goes on and on and on. And it just allows students to show what USF has to offer. Also, it's a major, we're looking at it as a major marketing tool to potentially bring in prospective students, any visitors coming to campus, knowing where to park. And of course, whoop. Yeah, I know, he's cutting me short, apparently. Who would have thought 2 years in we would have figured it out by now. So some of the projects we look at, we treat GIS kind of like a foundation for management. It really is a one-stop shop for campus information. We worked with a company called DRMP. They did all of our conversion from CAD to GIS. We flew LiDAR for the campus. We put in some survey monuments, and we did 3 utility phases where we did surveys and GPS data collections. I will avoid the long list of things that we've collected, but in short, we're still doing even further collection. We're probably looking at anywhere between probably 150 to 200 miles of utility lines. And at the moment, we're over 5,200 mapped assets just for the Tampa campus alone. And we're only a 1.5 square mile rectangle. So one of the big things that we had done was LiDAR, or light detection and ranging. And we had a company that did a flyover of campus, and it uses light penetration where it pulses down and we receive the signals back from the plane, and it gives us a precise 3D image or map of the surface characteristics of our campus. So you really can get an image of what are the elevations of our campus. We can pull out from these images, we can pull out elevations, we can pull out the building footprints, we can pull out hardscape, we can really get some accurate, and we had it within 6 inches of accuracy. So we had it pretty close for most of our stuff. And then, nope. Steve, can I steal you for a next slide, sir? I'm almost done. We got a lot here. Oh. Oh, can we go back probably 3 slides? One more? Yeah, there we are. So with this project, we also bought a brand new GPS unit that actually gives us centimeter accuracy. I could probably say on most of the stuff on a clear day, we're within probably 0.1, 0.2 inches on all the structures that we're mapping. And we are using some data collection tools through Esri that allows us to map everything from valves, as we were doing before, to mapping sinkholes, to mapping anything we want. I think Grounds was out there doing benches and trash cans a few months ago. So, so a long list of data that we've brought in over the past 4 years, kind of planning and infrastructure, campus safety, all the parking and transportation layers and utilities. And then what do we do with all this information? Now we've gone through how we've collected it, but we take this and we use it for different planning efforts. As you see up on the top right, that's the 2015 campus master plan. And we allow it to, we then can now look at the utilities digitally. We can zoom in and out, view it, again, all in the palm of your hand or just on your screen. We look at campus safety, so campus awareness before, during, and after an event that potentially happened. So it allows us to plan better for hurricanes. It also give trainings for any potential, say, active threats or any other incidents that may occur. Utilities infrastructure management, it gives us the better ability to map with 811 locates. So our utilities guys, again, have those maps in the palm of their hand just by zooming around, and it's actually following where their location is based on their phone or tablet, and it'll actually lead them up to the manhole, the valve, the transformer that they're looking for. I mean, they can't really miss the transformer, but then, yeah, it allows us to also share information out to other agencies. So we share out information to Hillsborough County 911, Pinellas, and Sarasota Manatee. We also share information with Esri's community maps to update the base maps that sit behind all of our applications. So again, like some of the applications that we've done one for our campus master plan. We looked at one for hurricane impact data, where we looked at over the past 5 major storms that we had, and then starting to look at where was all the damage on campus after the event happened. And then just some resources for you guys. And I believe this slide set will be shared with you guys, some links. So within our portal is gis.usf.edu. We have our research and art application that is that's where we've done a story map for the Institute of Research and Art, all of the public art, all of the points of interest for USF Tampa, St. Pete, and Sarasota. The USF Library has an extensive research hub and their COVID-19 hub, and then just some links for Esri. The Living Atlas is really cool to see just kind of some of the story maps and information that other business and entities have done as well. So I will leave this open for question and answer before I bring Rich into this. Do we have any questions? Oh, it's quiet.
So, raise your hand or just scratching?
Yes. I could refer to Rich on some of these too. Not that I can think of off the top of our heads. It's just been, we found a lot of utilities that we never thought was there, or things that were abandoned in place from a university that's 60 years old that a lot of times we've hit with a shovel or someone else has hit with a tractor.
We've also had systems that we knew were there that we couldn't find. We knew they were up, we couldn't find them, and that's where GPS has helped us say we know it's in this general area. We found a few manholes that have been covered over with about 3 feet of dirt that we had to dig and actually have to find. And
some of those manholes,
that's where
even had utilities that ran across the manhole lid that was underground.
Yeah.
So they ran new utilities above the manhole lid. So it was like, well, I guess we're not touching it.
That's where the tools that Rich is going to talk about kind of really help us, is to identify what is there. So what do you think, here's a question for you. What do you think is the wildest thing you could use GPS for? Knowing that it's information in one hand, it's a database of information tied in with a specific location, and then showing that graphically.
Not to necessarily be sitting still.
Right, that's right. So could you track wildlife populations with the GPS? Yeah.
Some of the new stuff, they show the great white shark migrations that come into the Gulf of Mexico, and
yeah,
you can watch the great whites going up and down the Atlantic.
That's kind of cool. So in master planning, we use it a lot for land use data. what's been there before, all of that kind of stuff. Basically, if you ever go to the property appraiser's website, you could click on your property that you actually live in and actually find out all kinds of information about that parcel of land. What it's valued, who sold it, who owned it the last 3 or 4 times, how much it was sold for, what type of building is on it, how big the building is on it. All that kind of information is real important when you go back and you're buying a piece of property. So you're a business person in real estate. You're looking at a piece of real estate that you want to buy, and okay, you find out that 20 years ago it used to be a gas station. Well, could be there's some contaminated dirt there that you need to plan on. So as you're developing it, you need to understand what the history of that piece of property might be. So do you think you could use it for astronomy? Yeah, so they're actually creating they have created a GPS map of Mars based on some of the research that they've done already. They've got one of the moon, so it doesn't necessarily have to be tied to this particular Earth. It's any place that you want to collect information and tie it to a specific location. It's been used extensively for the last 2 years to track COVID. You know, where are the pockets of high density? So if you look at the infographics, that's all generated by GPS that you may see online. All right, turning it over to our civil engineer, Rich.
All right, I'm going to go ahead and use the lectern. Just guys, let me know if you can hear me or see me behind this lectern. All right, Rich Piccinini. I'm the. Is it going? Or is it delay? There's a delay, or it's not going. Why is it not going? It's changing here.
It's changing there, yeah, but it's just not presenting what's on this screen.
Have to go into Teams. Looks like that's. Try.
It's still up there.
Still.
Sorry, guys.
All right. In the meantime, you guys, my stuff's not going to be nearly as good as Dan's. I mean, you guys are going to end up using a lot of the stuff that Dan has created, and it's very good information. My information is kind of just for me that I've gotten, and some of the tools that I'll be using to make sure stuff is secure and safe for what you guys do. Okay, let me know if anyone has any good jokes while we wait. Mine are all dad jokes. They're not very good.
It's all about lift stations.
No. That's a different presentation.
It's a dirty joke.
That's true. There we go.
There we are. Okay, that's one.
All right.
Is that me?
That's you.
All right.
That's you. All right.
Here we go.
Now we just have to present it to the people on Teams.
Oh, man.
There you go.
Try that.
No, that's a different screen up there.
You may have to click both.
Let's go to this one. Hold on. I don't know how to tell if the people on Teams can see
They're
the.
seeing what's on this screen.
All right.
Okay.
So can everyone see this, the slide with the bull and my name on the bottom?
No.
Negative. All right.
So,
That one?
all right. Well, you go talk and I'll play with this.
Well, that's where I'm talking from. I can't talk if
All right.
Oh, there we go. All right, so I used a lot of Dan's material that he collected, and I created a stormwater model. And there are several things you need in order to create the stormwater model. If you look on the picture on the left, that is kind of the LiDAR information that we got. And you can see the red areas are the higher portions of campus, and it goes down to the pink areas, which are where our retention ponds are, which are, in essence, the lower elevations on campus. Then the middle one shows all the pipes and inlets that we located, and we put it on a aerial just for convenience sake. And one of the last things you need is the ground cover, what it is. For instance, the difference showing where a building is and grass and/or roads. That'll help you model better where the stormwater actually goes.
Go to the next slide.
Yes, sir. All right. So when we imported the LiDAR into the model, this is kind of what comes in. It's a 2D mesh. And you can see there's a whole bunch of triangles, and each of the connection points, the center points, is an actual elevation associated with an elevation. And when you stick it on the model, the rain, a drop of water would go depending on how the elevations between those points are set up. The LiDAR. It gets, the data gets a little squirrely because if you bring it in over here, you're going to have a building, and the building would tend to go vertical, and that would make your lines be incorrect. So what we would have to do is go in there and create break lines for that so we can identify where the building points are. And then similarly with the roadways, when there's a curb and gutter, you can see this is palm, and that helps you direct the water into the inlets and curbs and gutters. Now, you look on the page, the X's and the circles are where the inlets and pipes are located. Next one. Does this work? Okay, so once we ran the model using the information shown, we were able to get some good information out of that. So for this example, I created a path of a stormwater pipe. And if you look on I guess as you face the board, the left, wait, we lost it. That is actually what comes out of the model. It's the stormwater pipe, the one that's on the bottom, the south end, you could see is it's full or over capacity, and as it gets down to the part that goes to the northeast, you can see the pipe is much larger and it has capacity for expansion. Okay. Also on this model, we are able to, let me back up a second. Each different agency requires you to model different type storms. Now, like the Department of Transportation, they'll require you to model a storm that allows the roadways not to flood. Similarly, the Water Management District wants to make sure the rivers and streams and people's homes do not flood. So when you create a model, if you look up here, that on the top there, that's a stormwater hydrograph, and that is how we actually model the storm over time. If you look at this heat model here, this is actually, we were able to take the data from a hurricane event and run it through this model so we can see how that event affected or would affect our campus. So this this shows what the model put out. So can I go back? Can I go back? Okay, so you see the hydrograph at about the 10-hour mark when the storm water starts to rise up, and then about the 12-hour mark you get the extreme peak of the storm, and then after that it kind of the storm starts to go down. So if you look at the model, what the model produced, after about 10 hours, you see the water, the blue areas, starts to puddle up and generate. And then by the 12-hour mark, which is the peak of the storm, you can see how much flooding is on the ground and around. In this case, most of that blue is in parking lots and areas where there wasn't enough inlets, so it's not as bad as it looks. And then at the 14-hour mark, when the storm starts to recede, you can see all the water is back where it's supposed to be, up in the circle for the stormwater ponds and the swales around campus. Okay, so now we'll get into the way that me and Dan kind of work together to get the data acquisition for all the maps and the stormwater modeling. So we use the GPR, which is over here, our lawnmower. Then we use, you're going to model this for me?
I'm going to model it?
Yeah, go ahead and get the Schonstadt for me. We're going to move to the Schonstadt. They can see this one. So this is, essentially it's a high-powered metal detector. And we use that to find, obviously, electrical and ductile iron pipes that are under the ground. So we can kind of get an idea where they are with that piece of equipment, and then we can verify with the GPR exactly where they are. And once we get an idea of where the pipes are, we use the probe rod. We use the probe rod to kind of poke the ground and actually physically determine that, yep, the pipe is actually there and get a depth on it. And when all else fails,
The mighty shovel.
we use out the trusty shovel.
Dig it up.
Be careful when you use the shovel. Some people have fallen using the shovel.
Damn. It was quite an event.
We can click one more. All right, GPR. GPR here, the piece of equipment works by emitting electromagnetic signals into the ground, and then recording the echoes, which when it hits something underground, that electromagnetic wave bounces back and is grabbed by the receiver. So you can see the unassuming fellow with the crooked hard hat in the top there. He's walking across the ground and he's emitting radio waves onto that pipe, and then it bounces off the pipe and it goes back to the data collector. So on the slide to the right, or the picture to the right, you can see as he's walking towards, there's a wave that gets shot down, and it's at a distance or an angle. So that's going to come up as a longer wave or a deeper wave in this case. And as you get to be right on top of the pipe, it'll be the shortest wave. So that would be the apex of your inverted parabola. So if you look on the bottom two pictures here, this bottom one is a picture of our campus atlas map. And you can see on the right, there's a 16-inch potable water line. And then as you move over, there's kind of a hot water line, and chill water line, and an irrigation pipe, which actually represents 5 pipes. 5 pipes.
What those humps are?
Yes, so you could see the first one is a very clear parabola illustrating the 16-inch water main. And as you get closer to the other cluster of pipes, you can see how it kind of gets a lot of bouncy, and there's a lot of different lines in there because it's hard to differentiate a cluster of pipes when they're together like that. So if you take a look at where that yellow line is, you say to yourself, well, there must have been a glitch in the equipment or something is wrong. Well, that actually identifies an area of very loose soil. Does anyone want to take a guess of what happens with very loose soil? Sinkholes. So this is an example of a sinkhole we had on campus. Don't look at the guy in the yellow vest. It was raining and it was a bad day. So you can see this hole is actually much bigger than it looks. And we ended up pumping over 20 cement trucks into that hole to try and get it filled. So 10 cubic yards. So, I mean, in particular hole, it kind of came out of the blue. It was in the road. The guy driving down, he stopped at a red light, and that's what happened to his tire. And then he got scared. He pulled forward, and then he saw this. And then over the course of the next couple hours, it ended up being that. So they can be very scary. And we also use this to scan areas before we put buildings on them as well, because let's just say on the first slide, 3 of the 4 buildings shown had anomalies underneath where the building is going to be. So they had to be remediated. So this piece of equipment is very useful. It does a lot of things to help the campus. And then you want to talk about the civil? Oh.
So this is basically between the GIS and all of the civil information that we've got. We can basically build a virtual model of whatever building we're building, whatever campus we're doing, and be able to simulate how they're going to react in certain conditions. We can do that with traffic. Our mechanical engineer does it with our chilled water and hot water systems. Rich does it with our sewer systems, our stormwater systems. We can now model how all of our different systems are going to operate under light loads, heavy loads, emergency situations, and figure out where we need to invest money in the future so that we can increase the capability of our campus. With that being said, we'll take the next thing, and I'm going to hand the presenting over to our friend Francis, who is remote, and let's see if we can get him talking. So Francis, you want to take control?
There we go.
All right. Let me figure out how to get you on the screen here. And turn the microphone off.
Can you hear me all right? Can you hear me okay, or? Can you hear me okay?
Yes, go ahead.
Okay, great. All right, hey everybody. Yeah, my name's Francis. I'm with OpenSpace, and yeah, I've been in construction tech about 6 years. Well, a little over that. So presentation today, I'll expand on this in a second here and kind of pop this out for you. But you know, ideally, we're going to talk to you a little bit about kind of our software and things like that, but also maybe talk a little bit about kind of the direction that that these engineers took, as well as myself in the career and choices we made to kind of help, you know, maybe encourage some folks there in terms of, you know, what to get involved in, where things are going, you know, depending on what your interests are. So I went to school originally for communications. That was kind of a easy major. Basically, you could just go ahead and like not have to show up to class. I liked that for the first year or two. And then eventually I switched to accounting and finance, which I thought was a good idea. And I graduated right into the 2008-2009 recession. So I was at Merrill Lynch. They ended up getting absorbed by Bank of America. And I was back on the picket line, going door to door, selling life insurance policies and as well as, you know, financial advice at 22. So needless to say, eventually I got to kind of this side of the game. I worked for Apple for a little while, then started my own company out in San Francisco. We kept that running, and then eventually I continued. They were like a Zillow competitor. They're still in business today, which is great, but eventually got over here to kind of the construction side. So one of the things I would say is that, you know, kind of looking at career paths as well as, you know, what do you want to have influence on? for better or for worse, there'll always be construction. So, as you know, with COVID-19 and everything kicking off, I was in New York City, and construction was one of the necessary businesses that started back up right away, right? So, and looking kind of at different verticals, everything from finance to, construction, things like that. And then, of course, looking into technology, because as we all know, it'd be nice to go and become a AI engineer for Tesla or something like that. But there's so many companies out there. You really got to look at kind of the leadership and choosing an organization to go work for. So the first company I joined in New York is a company called Honest Buildings. Brookfield, Oxford, some of the major asset managers and owners of commercial real estate in the world, Blackstone, and some of their portfolio companies were investors in us. We grew the company to about 150 employees, and then the number one of the top, essentially, project management software is a company called Procore that most GCs, subs, specialty contracts, and such know about, acquired us, right? So I was kind of part of that whole thing you always want. For some people at least, you start at a startup, you grow it, you get acquired, and then Procore went public. And so right before they went public, I ended up had a few job offers in kind of the AI space now, as construction is getting more AI focused, as you saw with everything from BIM models to clash detection to all this kind of really cool technology that's out there. And essentially, I interviewed with 4 companies. I had 4 offers. One thing I would suggest too, when you get out of school, try to get multiple offers and then pin them against each other, and then you can get kind of an easy bump in your salary. Just as kind of a side note, definitely helps. But this is where I wanted to go ultimately, and it ended up working out pretty well. The reason I chose this company though is because of kind of the brain trust here that you're looking at, right? These are all serial entrepreneurs, all PhDs from MIT and or Stanford in machine learning and artificial intelligence. Jeevan started a company called Siftio, got acquired by 3D Robotics. Mike started a company called Bluefin, got acquired by Twitter, right? And if this is what you want, these are the people to kind of get behind. So currently for us, we're looking to, eventually go public with this company. But, again, you want to follow the engineers, you want to follow the talent, and everybody in this room, if you have a background in computer engineering and things like that, I think, you hone your craft, you get really good at it, just like Jeevan did and Mike did. And then you can go into any vertical you feel could be disruptive, like construction, and really get involved and make a huge impact, which I'll show you with our product in a minute here. So that's the first thing I would look for. Once you kind of maybe look into graduating and stuff like that, looking into the job market and field. Look at the founders, make sure they have a pretty good track record. Getting in early stage, I think I was employee like 20 something here. We're about 180 now. We weren't as well financed as we are now. We just raised another 85 million, and everybody who works here has backgrounds in, construction or construction tech. So that's kind of the second thing. You want to look at kind of the founders and such first, then definitely look at kind of the technology, and also, how involved are our customers in our business. Most of the people work here, like I said, came from construction, and a lot of our customers are investors. So that's kind of put me in a pretty good position in our company, in a pretty big position to do pretty well. So these are some of the folks. Obviously, we work with the campus there, which is really has been a great experience, and I'll get into the product in a minute. But in kind of choosing your vertical and your career choice, like again, AI is here to stay, as we all know. Everything from like the metaverse to buying digital land. Well, this is kind of a way to digitize the land we currently inhabit, right? And you can do that through AI, which I'll share in a minute. Kind of as Steve was mentioned, the other thing that you want to that we wanted to focus on, and it's really one thing I would say is that having really good executives allows them to make pretty interesting decisions, right? So, I think Google's adage is like, don't be evil. Well, we have some of that, right? We're OpenSpace. We taught the machine how to do this. We didn't cut any corners, right? So in order to go ahead and read the way OpenSpace actually works is, and I'll show you here, it's a 360 camera like a GoPro, goes on your hard hat, you push one button, you go for a walk, and that's it. Within 15 minutes, you're going to get a Google Street View type of environment you can drive around. But in developing the software, the engineers didn't cut any corners. So they decided, we're going to go ahead and develop this and make sure that We, every half a second, 2 photos are taken. We built an algorithm and a machine that's going to go through every single photo and have, thousands and thousands of what we call the vision engine or, point cloud type dots on every single image to read everything that's going on. So then you can grow the product from there, which we have, since its inception. Other companies that were in the space, they decided to kind of outsource a lot of that stuff. And basically you'd have people overseas manually going through every individual photo, mapping it up. And you'll run into a bottleneck pretty quickly, as one of our competitors did. And then, of course, our CEO, who's a baller, for lack of a better word, he's done pretty well for himself, and he's also like he's kind, but he's cutthroat, and he wants the engineers to kind of be the winners in all of this. Decided to just give away the product that was a direct correlation of one of our competitors' products and put them out of business as well. So you want to be kind, but at the same time, this is a business, and we're developing automated 360 documentation. And when your algorithm and your software, happens to be light years ahead because you took the time to create it right, you should try to win at that. And that's essentially how it works, right? So you push a button, you go for a walk, and in 1 to 6 minutes, because now the machine's gotten smart enough, it will automatically create a 360 street view to drive around, and as I'm going to show you in a few minutes, versus manually doing this, takes people, 13 minutes per 10,000 square feet, and then you have to take all the photos, you categorize them, you put them in Dropbox or whatever it may be, you send it out. But with this, it's all automated. So that was kind of like our first thing that we wanted to get right. We want to focus on that. And now the machine reads what it's seeing. So similar to, Tesla in the driverless car, it can tell what a stop sign is, things like that. With this, it can tell, how much drywall has been put up, how much framing, how much electrical, how much mechanical, concrete, and we're going to start getting into, safety and things like that, as we progress. So let me jump into the overall product here. I'm going to get to your campus in just a minute, but just to give you kind of a quick idea. So this is the Mirror Tower. It's a pretty big project out in San Francisco. Somebody goes for a walk, automatically maps to your set of plans there. And then, of course, like I said, it's like kind of a Google Street View type of environment. You can kind of zip around, apologies for the latency here, but you can zip around and kind of take a look at everything that's going on. And this is big for a lot of different folks who are involved on this, right? So, number one, I can kind of split the view and look at yesterday's before the concrete pour, right? So it's good for all sorts of engineers that are on the project, as well as like project managers, to know, okay, well, this is what it looks like post-tension. There's certain, kind of things below the ground here that we need to be aware of. And it's creating essentially a catalog, a database to live with the assets forever. So if you think about USF and owning these, properties and all that jazz, they're going to want this type of live, historical, essentially visual data on all these, all these different assets that they're developing or ones that they're renovating, to live with the campus forever, right? So once you get into kind of higher ups, you look at like major, investment firms, like the Blackstones of the world, who own a boatload of real estate all over the place. From an asset management level, this is pretty important for them, especially looking into acquisitions or, doing some pretty heavy renovations on some of their existing portfolio. For the people on site, the GCs, the subs and such, having this type of data, being able to see through walls, floors, ceilings, whatever it may be, makes their job a heck of a lot easier. And then when it funnels up to the money, and the people getting paid for their work, or the investors, it makes the asset a lot more valuable to have a historical database of everything that's happened. The other thing too is we talked a little bit about BIM. So this can fully connect with BIM. So one of our big customers is that company down there who just moved their headquarters into Austin as well. You may have YOLO'd on the stock here or there, and hopefully did okay. But essentially, one of their big things has been coordination issues, right? And kind of developing one of their facilities, and understandably so. But by connecting it to BIM, it's going to give you the kind of that ability to see everything that's supposed to go on, understand whether or not you're going to have enough space for the duct work or the electrical coming in, right? As kind of the different trades funnel through the project, and make sure that everything can be connected. And this can do everything from, using BIM on the right-hand side here to measure different areas, use it for exterior, interior, it doesn't really matter. But you have this nice ability to kind of flow along with the project as you kind of, view everything that's happening and coordinate between kind of the different trades. One of the big things that we also came out with the new iPhone, right, is LiDAR. So again, just kind of trying to think about, as students, where you're going, kind of, after graduation and such too, and with jobs and things like that. One of the things, as you're seeing, like technology is moving at a pretty rapid pace nowadays. We hear like a new one all the time. But LiDAR is kind of an easy one for our engineers to have tied into. So essentially, one of the things that people run into on site, and you can do this kind of with the new iPhones, is things like, you got to measure a lot, right? So let me go ahead and see what we got here. So using this in a way that you can actually go ahead and measure, entire rooms or spaces, right? So this guy, you essentially just take your iPhone out now, you scan, the electrical box or, that own room right out of your pocket, and it's going to go ahead and create automatically a 3D model, right? So then you can use it for measuring, right? You can understand, essentially creating this kind of dollhouse type view, right? And the guy can kind of play with it on there. So it's right out of your pocket. So, not only is the hardware kind of moving and software is moving pretty dang fast, but it's also allowing you to literally take out of your phone. Typically, some companies would do this with kind of a laser scanner on a much larger scale. Those can be like $100,000 plus to get a laser scanner in there. This guy's using it in his phone. So you're watching, technology and such move at a pretty rapid pace. Let me see here. So for some reason, oh, there we go. So can you still see my screen okay now, the indoor performance facility?
Yes, we can.
Okay, cool. Thanks.
And we're getting close on time here, Francis.
Okay, so I'll wrap up right here. So here's your facility, right? And it's automatically, again, creating this kind of, nice like Google Street View, so you can drive around your facility. Over time, as you kind of, here's the renovation that you did. Over time, you're going to be able to kind of, see the facility mature, right? And then at the same time, you can go back in time and see what it used to look like, mid-renovation, right? And of course, help with pay apps and things like that. So, when people finish a certain percentage of the work, you'll be able to kind of approve the pay apps and things like that on the job. And then lastly, I can walk onto your campus at any time and take my cell phone out and see inside everything, in floors, ceilings, whatever it may be, right? That big facility you're putting outside there, I'll be able to see what the grounds used to look like, what it looks like today. So it helps, from everything from, a potential legal issue all the way up the ladder to maybe you're trying to do another renovation and you'll have this digital archive forever, kind of a skeleton type view on your project. I'll close with this. The last thing I wanted to mention is the AI now is tracking what drywall is, what electrical is, what mechanical is, et cetera. So when you walk by any of these on site, thousands of little dots are reading every single image individually, and it's automatically mapping and discussing, essentially sharing, hey, this is drywall taped, drywall hung. And this is big for projects to figure out whether or not they're going to be on time and as well as obviously on budget. Because it's going to show you, on average, we're doing about 1,500 square feet of drywall per week. You should finish by the 24th of February, for instance. So we built the machine to read. The first thing we did is, let's go ahead and create a Google Street View and do it the right way. And now the machine can scan and see everything in time and space and automatically count. Right. So as we kind of grow further along in this process, it's going to be able to start to make its own floor plans, measure rooms you're just walking through, all through just AI essentially. So, all right, I'll stop there. Let me go into the. There we go.
All right. So does anybody have any questions for Francis? I'll take that as a no, but one of the things you'll see, and let me turn this off. How's that? There we go. So one of the things you're starting to see is a lot of things are coming into the construction industry. As he said, the construction industry is ripe for disruption. In the last 100 years, because construction really is a manual process. It's a bunch of workers putting together Tonka toys or stuff like that in real life. And so there really has not been a huge increase in production capabilities over the last 100 years. There has been in almost every other industry, but construction has been one of those industries that's been slow to really improve its pace. You're going to start seeing that increase incredibly over the next few years. As you've heard the adage, you don't improve what isn't measured. So now we can measure productivity almost on a daily basis. How much drywall is actually being done? How much electrical is being done? We can measure that productivity and put some changes where it's actually made, where it actually makes a difference. What it also does, it allows us to build buildings in virtual time before we build them in real time. So we understand where the bumps of the road are going to be, so that we don't have to rework things when things don't coordinate. So you can really, if you go back and listen to some of the, I think it's session 4 in the AEC experience, we talked about how we're coordinating buildings before they actually get built. Rob, I'm going to turn it over to Rob, and he's going to talk about how we maintain the buildings and how we use technologies to really look at how we maintain the buildings, where we put our resources. And he's got about 10 to 15 minutes left, I think.
Do we have that?
We do.
All right. You want to get the,
I'll bring it on up. If I can. Right to the mouse. Mouse keeps disappearing. There it is. All right. Is that you?
that's me.
All right.
All right. I'm Rob Baynard, and I'm the USF roof guy. So I don't really have anything to do with with this technology on the actual building and development of the facility. But once we do take control of the building, then how do we use the infrared and the drone technology to maintain that building?
All right. Get that out of the way for you.
That would be nice. A well-oiled machine. All right. So we have part of a screen. All right, there's a whole screen. So we do a baseline survey of the roofs, make sure that we are getting what we bought, which is a dry roof. Then throughout the life of the roof, we'll continue to monitor them by either annual, semi-annual, whatever rate we feel is necessary for that facility on what we're seeing, and then continue to check it throughout the life cycle. And it helps us determine if the roof needs replacing or what our other options are. And it can also help in leak detection. And that's our fancy drone there, which is right up here at the front. Next slide. That pesky screen keeps popping up. Yeah. Okay. It was there, now it's not.
I have to find the mouse.
It's there.
Sorry. I did, and then now I'm trying to drag it. Or is it over? How many guys does it take to?
There we go. All right. Next slide, please. No?
It should be.
All right, I hope you enjoyed the presentation. All right. Thanks, Rich. So typical infrared survey methods, handheld is the old traditional. You had an infrared imager in your hand. You'd go up on a roof at night. You're working in the nighttime hours on the roof. Not really the ideal, working conditions, and it also doesn't give you the best quality of overall picture. So one of the other means that have traditionally has been aerial IR systems, where they had a sensor on an airplane. They fly up high, take a bunch of pictures, and then they just send it to you. But it tends to be higher altitude. You don't quite get the same results as being closer to the roof and being able to get rid of the false positives. So with the drones, we're flying anywhere between 100 to 400 feet, a little closer to the roof, still high enough to give a good image. 90 degrees gives us a better, image for the sensor. And we also take a digital image with every single IR image. So we're able to say, hey, that's a pile of granules or debris in the corner, which is giving me that hot spot. So that's not a real anomaly. So it helps us in that decision making a little easier. Next slide. So like I was saying, infrared for roofs, you have to do it at night. As you get the solar load, everything gets uniform during the day. The wet areas are going to retain that heat longer, while the dry areas reach ambient. And that delta T is what we're looking for. It's not telling us that that's wet insulation. That's just our brain knowing the difference of what we're reading. And then temperature difference is what's going to tell us. Next slide, please. Rich, you got it? So when you do an infrared survey, it's best to do a secondary means of testing to verify if your anomaly is wet insulation or not. So traditionally, core cuts are a great way to do that, but you're physically taking a sample of the roof. You're cutting a hole into the roof to determine whether it's wet or not. So if you're ready to go to design for a re-roof, it's a great way of proof positive. But when you have assets of 300 plus buildings on a campus, you don't want to poke a bunch of holes in your roofs if you don't want to, fix them right away. So using an impedance meter like the Tramex, it's a great way to test that. You take the known dry insulation, and then you also go over to your anomaly, and that verifies whether you're wet or not. It's a tool that's used in the roofing industry. It's a great tool. Next slide, please. So here we are, just taking the sample, and you can see the needle. It goes from reading completely wet. As we get closer to the dry, read 0. So it's a pretty accurate tool. Next slide, please. So back, please. Okay. So this is what a baseline survey looks like. Brand new roof, and in this infrared image, there's no anomalies. You get a little hot right here, but that's just because the sun's setting over there and the radiant heat there. But that's a clean, dry, brand new roof. Next slide, please. Okay. So for roof recovers or re-roofs, they're both technically called re-roofs according to code and everything, but a roof recover, you can keep your insulation, you remove the wet insulation, replace with dry, and then you can put a new membrane on. You can get a new warranty, 20-year NDL warranty with 30-year life expectancy, and it's better sustainability and better for budget. If you are over 25% by code, you have to remove everything and just replace it by completely new. Okay, next slide, please. So here's a good candidate for a roof recover because we only have a small portion of wet insulation that's been verified. So good candidate. Next slide, please. This is another one, even though we have sporadic, when you do the calculations, it's less than 25% anomalies, and we can cut those out. New membrane, new 20-year warranty. Next slide, please. Here's one that we actually did for a roof repair. We noticed that we had some isolated wet areas, less than 25%. We actually hired a contractor to cut out that insulation and just replace the membrane in those areas. So we have just effectively extended the life another 15 years. Next slide. This one is shot. This one, we have maybe 25% or less of not wet insulation, and it's a coal tar pitch roof. We need to replace that one. So next slide. So here's one of the fun ways we can use this for detecting leaks. So it's not always a good option to replace a roof. You can't just, we're the state, we don't have that kind of money. Even if you own your own buildings, you just can't do it. So we can pinpoint problems and see where it's coming in. Some decks are metal, water's coming straight through. Concrete, water can travel. You get the water come in on one spot, it travels to find a weak spot in the deck, and that's where it comes in. So in the next slide, we'll see how that can help us. So here you can see the anomalies. Up here, we weren't even looking in there. It's not leaking there. It's leaking over here. But when we pinpointed it with the overlay of the rooms, found this sheet metal clip was completely embedded through 2 plies of modified bitumen and creating a point of entry. Then over here, we found 2 conditions actually. This open lap and then this, it's no problem. It's what I do, Steve. So we also had a soil stack that was improperly flashed, and you can see we reflashed that to make it right. And that's what this big red spot is up here. So that solved a big problem that was very persistent. Thanks for the help of the drone and the infrared. Next slide. That's it. Any questions? All right. I like that. All right, Steve.
All right. So we do have about 2 more minutes left. So as you can see, there's a lot of different technologies that are developed in totally different industries that really are coming into the construction, the design realm to help us do better design, do better planning, do better maintenance on our buildings, and make a huge difference in where the money actually is invested for our university as well as in construction projects, design projects. Hope you found this interesting and not boring this time, but we will dig in our next open session. We'll talk about mechanical, electrical, and plumbing systems and the different, we've got 3 very different buildings, how the different systems are being furnished and supply the necessary air, water, all that other kind of stuff that we need to make the building run. So, any other questions? Yes, that's a dirty subject. All right. Yeah, I'm sorry. I'm borrowing Rich's dad jokes. All right. Thank you all very much. I appreciate it.